All right, today we're going to talk about tension problems. And these types of problems you'll also see in physics. So you guys need your note sheet out. Okay, the note sheet that we worked on yesterday. Okay, so you guys want to show the school how much you love math. So you hang this 50-pound banner from a string in front of the school. And what we're going to do is we are going to find those tensions in the string. Okay, so we're going to find T1 and T2. Okay, when you are finding these tensions, you are going to write them as vectors. All right, so our plan for this is we are going to set up a system of equations. Okay, and we are going to solve that system for T1 and T2. Okay, so you did solve some systems in Algebra 1 and in Algebra 2 with elimination and substitution. We're going to be using substitution to solve our system today. Okay, but how do we create our system? So it actually comes from two rules of logic. When you have tension in tension problems, the up forces equal the down forces. If they didn't, okay, if this down force, which is this 50-pound sign, that was not equal to the up force, what would happen to the sign? Fall down, break, right? Okay, if the up forces were stronger, then the sign would just keep being raised up and up and up. Okay, so the up forces have to equal the down forces in order to hold it in place. Now, the same thing has to happen with the horizontal forces. Okay, the horizontal forces have to be equal. Okay, the horizontal forces have to be equal to prevent motion. If the tension in this string was greater, okay, then it would be pulling that sign to the right. And if the tension here was greater, it would be pulling that to the left. Okay, so both horizontal components have to be the same so that the sign is not moving in any direction. So what we're going to do is we're going to set up two equations based on these two rules. So the first thing we're going to do is we are going to set the horizontal forces equal. Okay, and once you set the horizontal forces equal, you are going to solve that for T sub 1. Okay, and I know you might be thinking right now, I hate writing down directions, but please write down the steps for this. It is an involved process, and I want you to have something to look back at. So when you're like, I don't know what to do for this, hey, you have a nice little guide for that. All right, so first let's talk about what the horizontal forces are. In order to do that, we're going to be looking at this diagram. So you have a vector here. Every vector has a horizontal force and a vertical force. Okay, so the horizontal component would be here. The vertical component is there. Okay, so then we're going to use something from geometry. Okay, do you guys remember if these two lines are parallel, then this angle is going to be 37 because it's what type of angle? You guys got this. Come on, geometry. What type of angles are those? Yes, they're opposite interior angles. I knew we were having some of them. There are exterior ones as well. But yeah, alternate interior angles. Does that ring a bell? Yeah, they are opposites too. Okay, so what we're gonna do is we are just gonna draw a little diagram here so that we understand what is happening. Okay, you don't have to do this for every homework problem if you have this diagram, but I think it's going to help us make sense of why we're setting up these equations. Okay, so this is T sub 2. This is the tension. We said this is 37 degrees because of alternate angles. Okay, now the horizontal component is always the magnitude times the cosine of the angle. So this is the magnitude, T sub 2, times the cosine of the angle. You guys with me? Magnitude times the cosine is the horizontal component. The vertical component is the magnitude times the sine of the angle. All right, and then we're going to do the same thing for T sub 1, and then we're going to talk about what forces we're going to use in step 1. So in T sub 1, okay, again, I have this alternate interior angle situation here. Okay, so if that's 53 degrees, this is going to be 53 degrees. Oh, sorry that you can't see that. We'll write it out better here. So again, it's the same thing. Draw a little arrow. 53. Okay, so then this would be the magnitude times the cosine of 53. And that's our horizontal component. And then our vertical component is T sub 1 sine of 53. Okay, so that's how it relates to what we've been talking about the past few days. Horizontal component, vertical. Magnitude times the cosine, magnitude times the sine. Magnitude times the cosine, magnitude times the sine. Okay, so the horizontal forces are just the horizontal components. So the horizontal component here is the T sub 1 cosine of 53. The horizontal component here is the T sub 2. So we're just going to set those equal to each other. Okay, so we have T sub 1 cosine of 53 degrees equal to T sub 2 cosine of 37 degrees. Horizontal forces are equal. Now, in order to do a system of equations, we need to solve for one of the variables in order to do substitution. So in order to do substitution, I'm going to solve for T sub 1, which means I'm just going to divide both sides by the cosine of 53 degrees. Okay, which leaves me with T sub 1 equals T sub 2 times the cosine of 37 divided by the cosine of 53. Okay, so we set the horizontal forces equal. We solved for T sub 1.
Okay, now our next step is to set up another equation using our other rule. So we said the up forces equal the down forces. Okay, do we know what either one of those are? What's the down force? The weight, right? So the down force is for the sign is what? 50 pounds. Okay, so the down force is the 50-pound sign here. That's what's pulling down. What's holding the sign up? Yep, and the up force is going to be the vertical components. Okay, so it's these two components that are holding it up. So let's write down what those are so we can always plug something in. So the up forces are the sum, or is the sum, of the vertical components. The down force is going to be the weight. All right, so the sum of the vertical components is just going to be our T sub 1 sine of 53 degrees plus T sub 2 sine of 37 degrees. Okay, it is going to be equal to 50, that 50 pounds. Okay, so our up forces equal our down forces. Okay, so what we're going to do here after we set up the equation is we are going to substitute for T sub 1. Okay, so you're going to substitute equation from step 1. Okay, so instead of T sub 1, I'm now going to write this as T sub 2 cosine of 37 degrees divided by the cosine of 53 degrees. Okay, so T sub 1 becomes this. Notice that it's still multiplied by the sine of 53 degrees. So T sub 1 is now this equation times the sine of 53 plus T sub 2 sine of 37 equals 50. Okay, so once you substitute that equation, you are going to solve for T sub 2. Okay, so you're substituting the equation from step 1, and then we're going to solve for T sub 2. So substitute from step 1, solve for T sub 2. Okay, if you need to make sure that you are in degrees, you can do that now. And then we are going to be calculating. Okay, we're not going to be rounding until we get to the end of the T sub 2. So what we're going to calculate is the cosine of 37 divided by the cosine of 53. Okay, and do this with me. And then we're going to multiply by the sine of 53. Okay, when we are using a value that is not a rounded value, we show that by writing a dot, dot, dot. So we're going to write, this is 1.059, and I'm just going to put dot, dot, dot. I'm not rounding it at this point, but that is multiplied by T sub 2. So to find the decimal, you divide and multiply to get this decimal here. Okay, and then for this one, we just have to calculate the sine of 37. Okay, so this is 0.601 dot, dot, dot. Again, I'm not rounding yet. That's why I'm just putting my dot, 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 and I'm not even rounding. Okay, so what we're doing is we're finding this value that's the coefficient of t sub 2. We're finding this value that's the coefficient of t sub 2 because those are like terms. So now we're going to add them together. So to do that in your calculator, to add these non-rounded values, okay, you can enter that in. You can do plus answer. Okay, so you are going to add those like terms together. Okay, so you are adding this decimal and this decimal. That's where you're getting the 1.661. And then to get t sub 2 by itself, you have to divide by the coefficient. Okay, you are dividing by decimals, so that does add another layer of difficulty, but we're just going to keep those in our calculator. Maybe I should squiggle these so you don't think it's divide. So these are your like terms that you added. Okay, then we're going to divide. So we're going to do 50 divided by our answer. Okay, and then we can round here to the nearest hundredth, 30.09. That is our t sub 2. Okay, now that we found t sub 2, we want to find t sub 1. Okay, so I'm just going to go from left to right. So I'm going to make this where my step 3 is. So what you do is you substitute t sub 2 into the equation from step 1. Okay, to calculate that t sub 1 value. Okay, so we're going to calculate that t sub 1 value. Okay, so we have t sub 1 is equal to, see how this is t sub 2? We're going to plug in our t sub 2, and then we're going to do the cosine of 37 divided by the cosine of 53. Okay, so we got 30.09. That value is still in your calculator, so if you want to take that exact value and just do times the cosine of 37 divided by the cosine of 53, you can. You can also take the rounded value. Okay, and then you will get 39.93. Okay, our last step is going to be to write these as vectors, and you're going to notice some cool things that happen, and these are also things that can help you on an assessment because there are certain patterns that occur. So we're going to write t sub 1 and t sub 2 as vectors. So we're going to write the tension as a vector. They are the vectors here. So whenever you're writing your vector, remember t sub 1 consists of the horizontal component, t sub 1 cosine of 53, and t sub 1 sine of 53. Okay, we found that t sub 1 was 39.93. So we are going to substitute that in just a moment. We're not going to do it right this second. Okay, and then for t sub 2, okay, our horizontal component is t sub 2 cosine of 37, t sub 2 sine of 37. our T sub 2 is 30.09. Okay, so before we calculate those, I just want to let you know of a few things. One thing is that your vector T sub 2 is pointing in the direction of which quadrant? Quadrant 1. Okay, so for the second vector, T sub 2, that has to be in quadrant 1, which means you're going to have a positive value for both of your components. Okay, for T sub 1, that is pointing in the direction of which quadrant? Quadrant 2. So you should have a negative and then a positive. Now, this does not always naturally come out to be a negative, so we are going to have to make an adjustment there. Okay, so now we can calculate. So we're going to type in 39.93 times the cosine of 53. And we're going to do 39.93, the sine of 53. Okay, so for T sub 1, what you have, leave a little space here, is 24.03. Okay, and then 31.89 when you round. Okay, we are going to adjust that in just a moment. I just want to show you what happens with T sub 2. Okay, so with T sub 2, we are going to do 30.09 times the cosine of 37. What do you guys notice about that value? Why are you looking up at me? You guys got a calculator. Type it in. What do you get? What did you get? 24.03. So they're the same. Well, remember, what did we say about the horizontal forces? They have to be equal to prevent motion. Okay, so that makes sense. They're equal. Great. Okay, so when you have these, you are going to adjust it for the quadrant yourself. Okay, so you're going to put in the negative. You're going to make that adjustment based on the position. Okay, so you're going to adjust it for quadrant 2. So your final answer, both of these should add to 0. Okay, the sum of them should now add to 0. Okay, which is what you want to happen. Okay, so the sum of your horizontal forces should be equal to 0. There's also something special that happens with the vertical components. So remember, we said the up forces have to equal the down forces. And the sum of the vertical components should be equal to what? What do we write down? The sum of the vertical components should be equal to what? The weight. So if you add 31.89 and 18.11, what do you get? What do you get when you add them together? You can say it. I know it somewhere inside you. 50, right? It's 50 pounds. Okay, so the sum of your vertical forces equals the weight. Okay, so that will always happen. Okay? All right, so this is your final answer here. These are your vectors, the T sub 1 and T sub 2. Those are your tension vectors. Okay?